Good day everyone! I'm about to show you how to measure the dimensions of regular geometric shape. We need a rectangular solid shape and a circle shape, scientific calculator, and a ruler. I already measured the rectangle for the length, width, diameter, and thickness of height. For the rectangle, there is 15 centimeters. The width is 2 centimeters, diameter is 15 centimeters, and the thickness or height is 15 centimeters. And for the circle, I've already measured the length for 5 centimeters, the width for 10 centimeters, the diameter for 5 centimeters, and the thickness of height is 5 centimeters. To get the area of a rectangle, the formula is A equals length times width. So the length of a rectangle is 15 and the width is 2 centimeters, so it equals to 30 centimeters squared. To convert the measured rectangle length to hectometer, where length is 15 centimeters and we need to find the hectometer, and the answer is 0.0015 hectometer. To convert the measured circle diameter to nanometers, where diameter is 5 centimeters and we need to find the nanometer. 5 centimeters, open and close, 1 times 10 to the power of 7 nanometers divided by 1 centimeters is equals to 5 times 10 to the power of 7 nanometers, where the answer is 50 million nanometers.
I am Naquila. So I'm going to part B, which is measuring the mass of solids. So first, trial 1, we must first get the mass of our container, which is this, and it reads 84. So we're gonna write here 84 grams. So next we have our sugar here. Then we're gonna add 2 tablespoons of sugar in the container. So as you can see, it now reads 129 grams. Mass of the container with sugar now reads 129 grams. So we're gonna do the trial again. Now we're gonna measure the container again. Now reads 83 grams. Now we're gonna add the sugar. Now reads 128. So that concludes our data. Now we can get for the mass of the sugar by finding the difference between the mass of the container with sugar and the mass of the... Now that we have the mass of the container and the mass of the container with sugar, we're now going to find the difference between the mass of the container with sugar and the mass of the container to get the mass of the sugar. So 129 minus 84 is 45 grams, and in trial 2, the 128 grams, the mass of the container with sugar, and the mass of container in trial 2 is 83 grams. The difference between them is still 45 grams. So now we have the mass of the sugar, we can now conclude in the experiment.
I am Shallow Silva Alabado, and I am about to do the experiment of measuring the volume of a block of wood and the other shapes. We know that a volume is a derived quantity. That is because it is derived from its mass divided by its density. So that's what makes a volume derived. That being said, there are 2 ways of figuring out the volume of an object. Firstly is you have to use a calibrated material, a measuring tool such as a ruler or a straight edge. Next is to back it up with some formulas that will help you support and that will help you get to that derived quantity. And the second way to find the volume of an object is using the water displacement method. Now, what is this water displacement method? This is figuring out the volume of an object, or should we call it an irregular object that cannot be measured using by the ruler. So, for example, is a rock, and a rock doesn't have a definite shape of its own. Not all of it does. So if ever we are about to find the volume of that certain rock, we cannot just measure its sides, its diameter, considering of its irregularity. So this is when we use the water displacement method, is what I've said. So to do that, we'll need a graduated cylinder. We will have to fill it with water. You take out the measurement and remember that, because that will be the determining value as for the initial volume. Okay? Right after that, we will have to put in our object right onto it. And you will have to record again the next volume it will reach after the object has been dropped. So this is the purpose of comprehending and expressing it without due materials, but I hope I will get through while explaining. Okay, and then the next step is that we will have to subtract the final volume by its initial volume. That being said, that will derive us to our volume. And let us not forget about the said unit, which is usually mistaken by an ml in milliliters. So it's been like confused that is how it is measured about the unit of the volume, but instead it is grams per centimeter cube, which is what the volume of that object will be after using the water displacement method. So right over here I have my materials. First is we have our block of wood, and then we have our corkscrew, our measuring tool, which is a ruler, and we have our formula of the volume of the cylinder. This is the volume of the block of wood. Next is we need a pen and a paper to list down our results. And finally, our calculator, which will help us to perform the said operations on our formulas. About to determine the volume of this cylindrical wooden object. So to do that is we need our ruler or any calibrated tool that will determine its measurement in centimeters. It aligns down to the 3.5 centimeter of this straight edge, determining the height of this object. So it measures up to about 1.8 centimeters. We're about to perform the formula. So to do that, we have our formula sheet, which says that the volume of a cylindrical object is its diameter divided by 2, and then squaring it, multiplying it to the value of pi, and multiplying it by its height. So we all know that the half of the diameter is its radius. In your calculator, we will have to divide our diameter into 2, which will give us our radius.
So we have 3.5 divided by 2.
1.75, this will be our radius. Now let's do the formula.
Radius multiplied by the value of pi, and multiplying it again to its... Okay, let's not forget to square this, alright? Squaring the value of the 1.75, or squaring the radius, multiplying it by its pi value and its height, which is 1.8 centimeters.
Which gives us the result of 17.31, or approximately 17.32. So this is our volume for the cylindrical object. Time to measure in our wooden block. So the first step is to measure in the length. 12. This is 12 centimeters in length, and in height 4.5, and in width 7.9. Now we have our data. It's now time to calculate the volume. To do that, we will have to follow the formula, which is multiplying length by its width and its height. And by the help of our calculator, we will have to do that right now. So let us not forget to write about the shape. Anyways, this will be encoded, and yeah. So right here we have length times width times height, which will
give us 12 times 7.9 times 4.5.
and that will give us 426.6. And so that is how to calculate the volume of an object. Hi everyone, it is Shallow Silva Alabado from Group 2 again, and today's topic is we are about to measure in the volumes of water. So there are two ways of measuring the volumes of water. Firstly is using the computation method. We are gonna use the container that the water is being placed in. So for example is rectangular shaped container. So that is when we will take the length, width, and height of that container and then use a formula to compute the volume that the water is in right inside it. So the second type of figuring out the volume of water is through the graduated cylinder. So we will use this. If, for example, if the container that the water is been placed in is irregularly shaped, or if it cannot be calculated, this is when we'll use graduated cylinder. But for massive types of measuring the water volume, we will have to use the bigger types of this one, considering this only hold up to 10 milliliters of water. So right here I have a bottle cap that will tell us its equivalence in milliliters. So this is approximately 1 tablespoon of water if we're going to use the water to be measured in over here. So we are going to put in about one like this. This is equivalent to 1 tablespoon of water. And we must take note that this can only carry up to 10 milliliters of water. So we must take note of the calibrations as well. And let's start pouring. We are supposed to use a funnel over here, but considering that we don't have that and the lack of materials, so we'll just have to drop it right there carefully. Okay, and results. So let's not forget about the concept of the meniscus. So the meniscus is where we will have to look at it. This is the curve down or the curve up kind of thing that the graduated cylinder forms. So it depends on what and how you were instructed to do that. But in our case is that we will have to look at the bottom of the meniscus. So the meniscus is where you can read the calibration that will determine its volume in milliliters. So right over here we have 6.5 milliliters. So as the calibration shows, we have 6.5. The lower meniscus reading is it's 6.5. So for the second attempt, we have our graduated cylinder in and our bottle cap, and we are just gonna pour again, considering that this is approximately a tablespoon. And let's put it back in, and then we'll see how much it reads up to again. Now, looking at how it should be read, it measures up to 6.6 milliliters. So for a clearer look, reading through the bottom of the meniscus, this yields us to a 6 point, let me just put it down for stabilization. For a closer look, it still measures, and it does measure 6.6 milliliters via the bottom and the lower meniscus So for the second attempt, it rised up to a 0.1 milliliters. So that is how you measure the volume of a water through a graduated cylinder. Thank you.
Everyone, this is Arthur Sagrado from the group 2. So okay, this video is about the density of water part D. So this part is tackle about on how to calculate the density of water. So in order to calculate the density of water, there are step-by-step procedures that must to be followed. So first, I will introduce the material used in this procedure. So now we have a graduated cylinder which is about 100 ml, a distilled water with 50 ml, and a weighting scale about per grams. Now we will proceed to the experiment. So first step is we must determine the mass of our graduated cylinder. Is about 130 grams. And now pour the 50 ml distilled water into the graduated cylinder. So okay, now our mass of graduated cylinder with water is 175 grams. Okay, now with that. So use the mass and the volume to calculate the density of water. So okay, the formula used in this procedure is the density equals mass over volume. So okay, so in order to get the mass, we must subtract the mass of graduated cylinder with water to mass of graduated cylinder. So 175 grams minus 130 grams equals the mass of 45 grams. So the 45 grams is our official mass in this experiment. So where did they get the volume? So the volume is the water, is the distilled water used in this experiment. It is about the 50 ml. So mathematically our volume is the 50 ml. So okay, so density equals 45 grams over 50 ml is equals to 0.9 per milliliter. So our density is 0.9 grams per milliliter. So thank you everyone for listening and for paying attention in my discussion. So thank you.
Good afternoon everyone, I am Roberto Lamayo Jr. from Group 2 and I'm going to tackle about density of metal. But before that, I'm going to introduce to you my materials. This is my container, which is the graduated cylinder, my aluminum metal, and the weighing scale. And I also prepared the 35 ml water, which I put it in a beaker. So before I start, I would like to say that I have no support of like camera or tripod of doing this experiment, so I am only using one hand. So it is hard for me doing this experiment, so I hope you understand. So let's proceed to the instructions. There are 5. So the first is using your weighing scale balance, determine the mass of any clean dry container. So all of the problems, I calculated it before I started this experiment because it is hard for me to perform it while using one hand. So I hope you'll understand. So the mass of the container is 145 grams. I calculated it and it results to 145 grams. So number 2, obtain any piece of metal, transfer the metal to the container being weighed in the previous step, and measure the mass of the container and the metal together. So number 2, we're going to measure the mass of the container and the metal together. So the mass of the container plus the metal is 145 plus 14. 145 represents the mass of the container and the metal is 14 grams. 145 grams plus 14 grams, which is equals to 159 grams. So that is the mass of the container plus the metal, 159 grams. So number 3, pour 30 to 35 ml of water into your 100 ml graduated cylinder. Precisely measure this volume. So I already poured the 35 ml of water before, but I'm going to do it also right now. But I already calculated its volume, and it also equals to 35, and it will never change as what I have calculated in the number 3, so it won't change. So let's proceed to number 4. Carefully add the metal to the water, making sure not to lose any water to splashing. Also make sure that the metal is completely immersed in the water. Measure the new volume of the water plus the metal. So number 4 talks about measure the new volume of the water plus the metal. So I measured it. The volume of water inside the container is 35, and plus the metal, the volume is 36. So I also calculated the mass of the container plus the water and plus the metal, so it results to 185 grams. So again, the volume of water inside the container is 35, and after I put the metal inside the container with the water, the volume is now 36. And I also calculated the mass of the container plus the water and the metal. It equals to 185. So let's proceed to number 5. Analysis. Use your measured mass and volume obtained via water displacement of the metal to calculate the density of the metal. Use this value along with the table for density of substances to determine also the identity of metal. So number 5, we're going to measure the mass and volume of the metal via water displacement. So the measured mass of the metal obtained via water displacement, which is the 185 grams, and the volume of the metal via water displacement which is 36. So again, 185 grams, that is the mass of the metal via water displacement, divided by 36. 36 is the volume of the metal via water displacement. So if we're going to calculate the density, we're going to divide the mass and the volume. So we're going to divide 185 grams and divided by 36, which equals to 5.14. So that concludes my experiment, guys. So the density of the metal is 5.14. So the formula of getting the density is mass divided by volume. So that concludes my experiment, and thank you.